Would you mind if I told you the whole universe around us is completely fake? I bet you would, because for decades, you've believed it's real. And now I'm saying it's just like a mirage in the Sahara. I know your head is already spinning with questions like, is everything around me just a brain-constructed reality? How do scientists know the universe might be fake? And can we trust our senses anymore? To answer all these burning questions, we're traveling back to the 5th century BCE, 2,472 years ago, when this wild idea first popped up. Plus, we'll explore some world-recognized theories that suggest the universe is a big cosmic illusion, and your brain is the culprit behind it. Well, I know it's hard to believe that the whole universe you've known forever, galaxies, stars, planets, and everything, is just an illusion. Suddenly, after decades of believing it's all real, you're told it's fake. But hold on, because this isn't just some wild idea. Scientists have actually backed it up with examples and evidence. The first clue about this idea is that our brains are the biggest pranksters around. They can show us things that aren't real at all. And this trickery has a lot to do with how we perceive the universe. I know it sounds pretty crazy, but that's what our intellectual scientists have said. So they say our brains are like master illusionists. Neuroscientists like Anil Seth say what we see, hear, and experience isn't a direct look at the real world, but a model our brains create based on sensory data. This model helps us get around and understand our surroundings, but it's not always spot on. In fact, our brains sometimes show us a wonky version of reality. Understand it with the concept of optical illusion. They're perfect examples of how our brains can be fooled. Take the famous Miller-Lyer illusion. Two lines of the same length look different because of the arrowheads at the ends. Simple, yet it totally messes with our heads. Or how about the rotating snake illusion by Akiyoshi Kitaoka? Static images look like they're moving just because of the way colors and shapes are arranged. These illusions are like our brains playing tricks on us, reminding us that what we see isn't always what's real. But it's not just our senses at play. Our brains use past experiences and knowledge to make sense of new info. Cognitive scientist Donald Hoffman explains this process helps us predict and react to our environment, but it also brings in biases and errors, like confirmation bias, where we tend to believe information that confirms what we already think and ignore the stuff that contradicts it. Sneaky, right? So what's the big deal? These insights suggest that our experiences might not show the true nature of the world. If our brains can be so easily tricked and biased, how can we be sure what we see is real? It's a pretty wild thought. Are we just experiencing a filtered, brain-made version of reality? Think about it. Every decision we make and every reaction we have is based on our perception of reality. But if that perception is flawed, how accurate are our judgments and actions? It makes you wonder if there's more to the world than what our senses show us. Take the research by neuroscientist V.S. Ramachandran, for instance. He found that brain damage can totally mess with perception. People with phantom limb syndrome feel sensations in limbs that aren't even there anymore. It shows just how much our brains are involved in creating our sense of reality, and how easily that can be disrupted. But hey, if you think it's just scientists talking about the universe being fake, think again. This idea pops up everywhere, including philosophy as well. Philosophers have been wrestling with this for centuries, debating the difference between objective and subjective reality. Objective reality is all about the belief that there's a world outside our minds, that exists independently of how we perceive it. On the flip side, subjective reality says that our perceptions and experiences shape what's real. One of the first big thinkers to dive into this was Parmenides, way back in the 5th century BCE. This pre-Socratic philosopher had a pretty wild idea where he said, "The world we see and touch is just an illusion." Parmenides argued that true reality is unchanging, unified, and timeless. According to him, the idea of change is impossible because it implies that nothingness exists, and he was convinced that nothingness couldn't be a thing. So he concluded that the world we interact with is just a bunch of appearances, and only through reason can we get to the real, unchanging nature of reality. This philosophical stance brings up a big problem, that if our senses are unreliable, like Parmenides suggested, how can we know anything for sure? This question has bugged philosophers forever. Take René Descartes, for example. In his 1641 work, Meditations on First Philosophy, he doubted the reliability of our senses big time. Descartes proposed that the only thing we can be absolutely sure of is our own existence. which he summed up with the famous line, cogito ergo sum, I think therefore I am. Descartes' skepticism highlighted just how tough it is to get true knowledge in a world where our senses might trick us. Then things get even crazier when you throw quantum theory into the mix. Developed in the early 20th century, quantum theory suggests that particles can exist in multiple states at once, and that their behavior is fundamentally unpredictable. This totally flips the script on the deterministic universe idea that classical physics was all about. In 1935, Einstein, Podolsky, and Rosen published a paper questioning whether quantum mechanics was complete, suggesting there might be hidden variables we can't see that determine the state of quantum systems. But Niels Bohr, a big name in quantum mechanics, wasn't having it. He supported the Copenhagen interpretation, which says particles exist in a superposition of states until we observe them. Bohr's view actually lines up pretty well with Parmenides' idea that our sensory experiences don't give us the full picture, and reality might be way different from what we perceive. More recently, physicists like John Bell added to the conversation. Bell's theorem, published in 1964, showed that no local hidden variable theories could explain all the predictions of quantum mechanics. This suggests that the universe might indeed be fundamentally indeterministic. These philosophical and scientific ideas come together to seriously challenge the notion of a straightforward, objective reality. They suggest that what we see as reality might be a complex mix of sensory information, cognitive processes, and random quantum events. Now, try to keep a straight face and don't start doubting your coffee mug or the phone in your hand. Trust me, people don't want to see you giving weird looks to everyday objects. Imagine telling them that everything around them is just an illusion. They might think you've lost it. But what if I told you we could merge these two ideas and get a third, more holistic one? Yep, I'm not just making this up. Consciousness is one of the most profound mysteries in both science and philosophy. The Oxford Dictionary of Psychology defines it as the normal mental condition of the waking state of humans, characterized by perceptions, thoughts, feelings, and awareness of the external world. But despite tons of study, scientists and philosophers still can't agree on what consciousness really is or where it comes from. One of the coolest theories linking consciousness to the physical world comes from physicist Roger Penrose. In his 1989 book, The Emperor's New Mind, Penrose argued that human consciousness isn't just some algorithmic process. Instead, he thinks it arises from quantum processes happening in the brain. Penrose, who snagged a Nobel Prize in physics in 2020, suggests that these quantum effects might explain the non-computational aspects of thought that classical physics just can't handle. He teams up with anesthesiologist Stuart Hameroff, proposing that tiny structures called microtubules in our neurons might be sites of quantum processing. So they're basically saying consciousness could be tied to the strange world of quantum mechanics. Another big player in the study of consciousness is the Integrated Information Theory, EIT, developed by neuroscientists Giulio Tononi and Christoph Koch. EIT says consciousness is all about a system's ability to integrate information. They even came up with a measure called phi to quantify this integrated information. According to IIT, systems with higher phi values have more complex and unified consciousness. This gives us a mathematical way to understand consciousness and suggests it can show up in varying degrees in different systems, not just in human brains. Now, the idea of phi shakes up traditional views by suggesting consciousness isn't just for living things. This leads us to the wild notion of panpsychism, the idea that consciousness is a fundamental property of all matter. Philosophers like David Chalmers and Galen Strawson argue for this perspective, suggesting that even the tiniest particles in the universe might have some form of consciousness. It proposes that the universe is not solely composed of inert matter, but also contains a form of consciousness or awareness at every level. This idea challenges the conventional scientific view that consciousness arises only in complex organisms with sophisticated nervous systems. Panpsychism suggests that if consciousness is intrinsic to all matter, then our understanding of the universe is incomplete and possibly flawed. This has implications for the concept that the universe might be fake or an illusion. And I also mentioned earlier that quantum theories are also in the running to prove the universe is just a beautiful illusion. So let's explore that in more detail. Quantum mechanics has flipped our understanding of the universe on its head, challenging everything we thought we knew from classical physics. One of the biggest game changers here is Heisenberg's uncertainty principle, cooked up by Werner Heisenberg in 1927. This principle basically says you can't know both the position and momentum of a particle at the same time with perfect accuracy. The more precisely you know one, the less you know about the other. It's like trying to get the last piece of a puzzle, but every time you get close, someone moves it. This limit, by the way, is tied to something called Planck's constant, divided by 4 pi for the math nerds out there. So why is this a big deal? Well, it means we can't make precise predictions about particles like we can with classical physics. In the quantum world, particles are like the ultimate pranksters, existing in a state of probability until someone observes them. Now, this idea of intrinsic uncertainty is a far cry from the old-school deterministic universe of Isaac Newton. Newton's laws, from the 17th century, painted a picture of a clockwork universe where, if you knew the starting conditions, you could predict everything. Einstein came along in the early 20th century with relativity, adding more detail, but still keeping things pretty deterministic. But then, quantum mechanics showed up and tossed all that certainty out the window. Some physicists, including Einstein, couldn't handle this randomness. Einstein famously said, "God does not play dice with the universe." He thought there had to be hidden variables, some unknown factors, that would explain the apparent randomness. But then John Bell in 1964 threw a wrench in that idea with Bell's theorem. He showed that no local hidden variable theories could match all the predictions of quantum mechanics. If hidden variables exist, they must be non-local, meaning they can affect distant particles instantly. This idea messes with our classical sense of cause and effect, and it gets weirder. John Wheeler, a physicist, loved thought experiments that highlighted the oddities of quantum mechanics. One of his famous ones is the delayed choice experiment, an upgrade to the double-slit experiment. In the double-slit experiment, particles like photons act like both particles and waves. They create an interference pattern when not observed and act like particles when observed. Wheeler's version adds a twist. You decide how to measure the particles after they've gone through the slits, but before you detect them, the particles seem to decide how to behave based on your choice, even though they've already passed through the slits. It's like the particles are playing a cosmic game of gotcha. But while Heisenberg's uncertainty principle gives us a sneak peek into the universe's tricky nature without spilling all the beans, there's a principle that doesn't hold back anything. And that is the holographic principle, a revolutionary concept that suggests the universe we see might just be a giant projection. This idea has its roots in black hole physics. Researchers found that the information content of a black hole, measured as entropy, is related to the area of its event horizon, not its volume. This odd finding hinted at a deeper, more mind-bending nature of reality. Physicists Gerard 't Hooft and Leonard Susskind took this idea and ran with it, developing the holographic principle. They proposed that just like a black hole's info is stored on its two-dimensional surface, the entire universe's information could be encoded on a distant, two-dimensional boundary. So everything we experience in our three-dimensional world, including space and time, might be a projection from this flat surface. If our universe is a holographic projection, it means that our everyday experiences, the solid feel of objects, and the flow of time are all part of a grand illusion. Picture our three-dimensional world as a hologram, where depth and form are tricks created by light on a flat surface. This suggests our perception of a vast, expansive universe is just a fancy rendering from a lower dimensional reality. Living in a holographic universe has some deep implications. If reality is just a projection, it challenges the very idea of materialism. What we think of as solid matter might not be fundamentally real. Instead, it could be a complex play of information encoded on some distant boundary. This fits with some interpretations of quantum mechanics, where observing something changes its state. This holographic idea raises some pretty wild existential questions about our place in the cosmos. Are we, as conscious beings, just projections too? If our physical reality is a hologram, does that mean our consciousness is also encoded on this two-dimensional surface? These questions push us to rethink the nature of existence and what reality really is. Moreover, you might have read in your science books that the brain is the powerhouse of the human body and the most active part. Without it, your body can't function because everything processes there. But believe me when I say your most crucial companion is also the biggest deceiver ever. It's hard to believe, but our brain has proven that it can be tricked pretty easily. Visual illusions are like the brain's way of reminding us that what we see isn't always what's there. These illusions mess with our brain's processing mechanisms, showing us how complex our interpretation of sensory information really is. Take the moving hole illusion, for instance. It's just a static image, but it looks like it's expanding or contracting. This magic trick is all about manipulating colors and patterns to make our brains think there's motion when there isn't any. Then there's the diagonal motion illusion, where alternating black and white patches make a static object seem like it's moving diagonally. These illusions show how much our brains rely on context and expectations to make sense of what we see. Neuroscientists love studying how these illusions mess with our brains. Using fancy tools like functional MRI, they found that visual illusions light up specific areas of the brain responsible for motion detection and shape recognition. These studies reveal that our brains don't just passively receive information, they actively construct our perception of reality by mixing sensory data with what we already know and expect. Now let's dive into the illusionistic brain of William James, the guy who proposed the multiverse concept, and how it challenges our understanding of reality. This idea also supports the notion that the universe we perceive might be an illusion. Coming out of cosmic inflation theory, the multiverse suggests our universe is just one of many bubble universes that exist simultaneously. Cosmic inflation theory, which took shape in the early 1980s, suggests the universe went through a crazy, fast expansion right after the Big Bang. This rapid inflation could have created countless separate regions, or bubble universes, each potentially running on different physical laws and constants. These bubbles are isolated from each other, meaning while we live in one, there could be countless others with entirely different properties and structures. Evidence for the multiverse theory comes from observations in cosmology and quantum mechanics. Take the cosmic microwave background radiation, for example. It's the afterglow of the Big Bang, and it shows fluctuations that some scientists think could be signs of other bubble universes. Plus, the fine-tuning of physical constants in our universe, like the conditions that allow life, suggests that among many possible universes, ours just happens to have the right conditions. This idea becomes more plausible if there are countless other universes with different conditions. The implications of the multiverse theory are mind-blowing. If multiple universes exist, each with its own set of physical laws, it messes with the idea of a singular objective reality. Instead, reality turns into a kaleidoscope of possibilities, with each universe representing a different facet of existence. This aligns with the idea that our universe is fake, or at least not the only reality. It suggests that what we see as the totality of existence is just one version among an infinite array of alternatives. It's like discovering your favorite movie is just one of an infinite number of sequels. And if that doesn't make your brain spin, I don't know what will. All these theories are basically telling us the universe is fake and everything in it is too. And guess who's behind it all? Our brains, the ultimate culprits. But hold on. What if even these ideas about the universe being fake are just more tricks our brains are playing on us? When you start questioning reality, it's like nothing is real, not even these theories.